Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everybody. So today we are going to learn about random variables topic 9. Okay. A random variable is a set of possible values from a random experiment. We can use capital letter like X or Y to represent the variable. For example, if we are tossing two fair coins, we could get either head or tail. So now, let X is a random variable that represents the number of head appearing. So, we can use tree diagram to list the outcomes. The first toss, we can get either head or tail. Same goes for the second toss. The probability is either getting head or tail. The probability of getting head is 1/2, tail also 1/2. Don't forget to write the probability on each branch. At the end of the tree diagram, we list the outcomes. So the outcomes here is head, 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 tail, tail, head, and tail, tail. So X is referring the number of head appearing. So the number of head here is 2, 1, 1, and 0. So now we can represent the variable X that referring the number of head appearing by using table. We start from 0, which is 0 head. 1 means 1 head, 2 means 2 head. The probability of getting 0 head means tail, tail. The probability is 1/2 times 1/2. So we get 1/4. 1 means 1 head, which is head, tail, or tail, head. Head, tail, or tail, head. So the probability of getting head, tail, 1/2 times 1/2. So we get 1/4. And the probability of getting tail and head is 1/2 times 1/2. So we get 1/4. So the probability of getting 1 head is 1/4 plus 1/4, so we get 2/4. 2 means 2 heads. So the probability of getting 2 heads is 1/2 times 1/2, 1/4. Okay, look at next example. If 2 dice are tossed, and let random variable Y referring the sum of the scores on 2 dice. So, firstly, we must list all the outcomes. You can use table to list the outcomes. Okay, this row shows the outcomes of the first die, and this column shows the outcomes of the second die. If the first die you get 1 and the second die you get 1, so the sum of the scores is 2. If the first die you get 2 and the second die you get 1, so the sum of the scores is 3. Here means 3 on the first die and 1 on the second die. So the sum is 4. Continue the process until the biggest number on the dice, which is 6 and 6. And the sum is 12. From this table, you can see that the smallest value is 2 and the biggest value is 12. So, you can construct table to represent the random variable Y that referring the sum of the scores. So we start from 2, 3, 4 until the maximum scores, which is 12. And the probability of getting 2 is 1/36. And the probability of getting 3 is 1, 2. 2/36. And the probability of getting 4 is 1, 2, 3, which is 3 out of 36. So list all the probabilities until the maximum score, which is 12. So the probability of getting 12 is 1 out of 36. So this table is the example of discrete random variables. Actually, there are two types of random variable, which is discrete and continuous. Discrete random variables is a value that obtained by counting. For example, the number of cars sold at a dealership during a given month, or the number of students in KMPH. Continuous random variable is uncountable and obtained by measuring. For example, the weight of students in a class and time taken by workers to complete the assignment. As I said in the first video, there are two types of random variable, which is discrete and continuous. In this video, we are going to discuss about discrete random variables. X is a discrete random variable if it satisfies these two conditions. You need to memorize these two conditions. These two conditions is very important. The first one is the probability must be between 0 and 1. And the second one is sum of the probabilities must equals to 1. The probability distribution for discrete can be represented in the form of table, function, or graph. This is the example of the probability distribution table. And this is the example of probability distribution function. As we can see here, the value of x is countable and not in interval. We also can find the mode for discrete random variable. Mode is the value of x with the highest probability. If distribution function are known as CDF. The symbol for CDF is capital F or Px equals or less than x. We also can find median for discrete random variable. We denote as M for median. And the formula is Ps less and equals to M is equals to 0.5 or capital Fm is equals to 0.5. Other than that, we can find expectation and variance for discrete random variables. Expectation, also known as mean, and denoted by Ex or mu. The formula for expectation or mean is sum of x times with the probability. Variance denoted by var x or sigma squared. And the formula for variance is expectation x squared minus mean squared. There are 6 properties for expectation and variance. The first one is expectation of A is equals to A, where A is a constant. It means expectation of a constant is constant itself. For example, expectation of 10 is equals to 10. The second one is expectation of Ax is equals to A times with the expectation. So we can take out the constant outside and multiply by the expectation. For example, expectation of 10x is equals to 10 times with the expectation. Properties number 3. Expectation of Ax plus B is equals to A times with the expectation plus B. For example, expectation of 7x plus minus 2. So it becomes 7 times with the expectation minus, okay, expectation 2 is 2. Properties number 4. Variance constant is equal to 0. Okay, for example, variance 5 is equal to 0. Properties number 5. Variance of AX is equal to A squared times with the variance X. For example, variance 3X. So, we can take out the constant of X, then square it, then multiply by the variance. Properties number 6. Variance of AX plus B is equal to A squared variance X. For example, variance of 7X minus 4. So, the constant of X here, we can take out and square it, then we multiply with the variance. Minus variance constant, which is 4, is 0. So these properties are true for discrete and continuous random variables. And the formula for standard deviation is square root of variance. Example 1. A probability distribution is given by this function. Firstly, we must identify the types of random variable, either it is discrete or continuous. Actually, we can identify the random variable through its name. Probability distribution function is for discrete random variables. For continuous, it is probability density function. Second, we can look at the value of X here. The value of X here is countable and make sure it is not in interval form. A continuous random variable, the value of X is in some interval of numbers. A. Show that X is a discrete random variable. So remember the important condition that I have mentioned in the previous video, which is sum of the probabilities must equals to 1. So, we start from X equals to 1 until X equals to 7. So, Px equals to 1 plus Px equals to 2 plus Px equals to 3 plus Px equals to 4 plus Px equals to 5 plus Px equals to 6 plus Px equals to 7. And when X equals to 1, the probability is 0.1. X equals to 2, the probability is 0.2. When X equals to 3, the probability is 0.1. When X equals to 4, the probability is 0.2. When X equals to 5, the probability is 0.1. When X equals to 6, the probability is 0.2. And the last one, when X equals to 7, the probability is 0.1. So, we add up all the probabilities and the answer must equals to 1. This is how to show the function is a discrete random variable. B. Construct the probability distribution table for X. We just transform this function into a table. The first row is the value of X. So we start from 1, 2, 3, 4, 5, 6 until 7. The second row is for probability. When X equals to 1, the probability is 0.1. When X equals to 2, the probability is 0.2. When X equals to 3, the probability is 0.1. When X equals to 4, the probability is 0.2. When X equals to 5, the probability is 0.1. When X equals to 6, the probability is 0.2. And the last one, when X equals to 7, the probability is 0.1. C. Sketch the graph of probability distribution function. Firstly, we must draw an axis. The probability versus the x. So x, we start from 1 until 7. So x equals to 1, 2, 3, 4, 5, 6, and 7. So the value of probability, we use 0.1 and 0.2 only. So read from the table, when x equals to 1, the probability is 0.1. Draw a vertical graph. When x equals to 2, the probability is 0.2. When x equals to 3, the probability is 0.1. When x equals to 4, the probability is 0.2. When x equals to 5, the probability is 0.1. When x equals to 6, the probability is 0.2. And the last one is when x equals to 7, the probability is 0.1. D. Determine the mode of the distribution. Mode is the value of x with the highest probability. As we can see from the graph, the highest probability is when x equals to 2, 4, and 6. So the modes are x equals to 2, 4, and 6. E. Find the cumulative distribution function for x and determine the median, hence sketch the graph. So by definition, CDF or capital Fx is equals with the probability of x less than equals to x. So to find the CDF, firstly, you must add one row below the probability. F1 means Px is less than equals to 1. So the value is 0.1. F2 means Px less than equals to 2. So we add the probability when x equals to 1 plus the probability of x equals to 2. So we get 0.3. F3 is equals to Px less than equals to 3. So the probability is 0.1 plus 0.2 plus 0.1. So we get 0.4. F4 means Px less than equals to 4. Simply, we can add F3 plus the probability of x equals to 4. So we get 0.6. F5 means Px less than equals to 5. So we can add up F4 plus with the probability of x equals to 5. So we get 0.7. So F6 is 0.7 plus 0.2. So we get 0.9. And the last one is F7, 0.9 plus 0.1. So we get 1. So remember, the last column of CDF must equals to 1. E. Find the cumulative distribution function for x and determine the median, hence sketch the graph. So by definition, CDF or capital Fx is equals with the probability of x less than equals to x. So to find the CDF, firstly, you must add one row below the probability. F1 means Px is less than equals to 1. So the value is 0.1. F2 means Px less than equals to 2. So we add the probability when x equals to 1 plus the probability of x equals to 2. So we get 0.3. F3 is equals to Px less than equals to 3. So the probability is 0.1 plus 0.2 plus 0.1, so we get 0.4. F4 means Px less and equals to 4. Simply, we can add F3 plus the probability of x equals to 4. So we get 0.6. F5 means Px less and equals to 5. So we can add up F4 plus with the probability of x equals to 5. So we get 0.7. So F6 is 0.7 plus 0.2. So we get 0.9. And the last one is F7, 0.9 plus 0.1. So we get 1. So remember, the last column of CDF must equals to 1. The question asks you to find the cumulative distribution function. So, we must convert the CDF table into a function. Remember, the CDF function must start from 0 and end with 1. Read from the table. F0 is when x is less than 1. F1, the fx is 0.1. So x is greater and equals to 1 but less than 2. F2 is 0.3. So the interval is x is greater and equals to 2 but less than 3. F3 is 0.4. So x is greater and equals to 3 but less than 4. F4 is 0.6. So x is greater and equals to 4 but less than 5. F5 is 0.7. X is greater and equals to 5 but less than 6. F6 is 0.9 and x is greater and equals to 6 but less than 7. And finally, 1 when x is greater and equals to 7. Okay, the next question is find the median. The formula for median is capital Fm is equals to 0.5. Look at the CDF function. The median is in the interval of 4 to 5. So median is m equals to 4. Okay, next question is sketch the graph of CDF. To sketch the graph of CDF, draw an axis. Fx versus x. So x is start from 1 until 7. 1, 2, 3, 4, 5, 6, and 7. And the CDF 0.1 until 1. So we start from 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 until 1. To sketch the graph of CDF, read the CDF function. When x is less than 1, the fx is 0. So less than 1, fx is 0. Open interval for 1. When x between 0 and 2, the fx is 0.1. 1 from 1 to 2, so the fx is 0.1. So then circle for 1 and empty circle for 2. 0.3 for the interval 2 to 3. 2 to 3, 0.3. When fx is 0.3, the interval is from 2 to 3. So then circle for 2 and empty circle for 3. On the interval 3 to 4, fx is equals to 0.4. Then circle for 3 and empty circle for 4. On the interval 4 to 5, the fx is 0.6. Then circle for 4 and empty circle for 5. Fx is 0.7 on the interval 5 to 6. Empty circle for 6 and then circle for 5. 0.9 on the interval 6 to 7. Then circle for 6 and empty circle for 7. And the last one, when x greater and equals to 7, the fx is 1. So this is the graph of CDF function. F. Find the probability when x less than 5 but greater than 1. So we can take the value of x equals to 2, 3 until 4. So px equals to 2 plus px equals to 3 plus px equals to 4. The probability when x equals to 2 is 0.2 and the probability when x equals to 3 is 0.1. The probability when x equals to 4 is 0.2. We add up all the probabilities and the answer is 0.5. Question number 2. Find the probability when x less than equals to 5 but greater than 1. Here is not included 1, so we start from 2, 3, 4 until 5. So x equals to 2 plus px equals to 3 plus px equals to 4 until px equals to 5. When x equals to 2, the probability is 0.2. When x equals to 3, the probability is 0.1. When x equals to 4, the probability is 0.2. And when x equals to 5, the probability is 0.1. So we add up all the probabilities and the answer is 0.6. Okay, question number 3. Find the probability when x less than 5 but greater and equals to 1. So here means include 1, so we must start from 1 until 4. So px equals to 1 plus px equals to 2, px equals to 3 until px equals to 4. When x equals to 1, the probability is 0.1. When x equals to 2, the probability is 0.2. When x equals to 3, the probability is 0.1. And when x equals to 4, the probability is 0.2. So the answer is 0.6. Number 4. Find the probability when x greater than 5. So from probability distribution table, you can see that when x greater than 5 means we can take the value of x equals to 6 and x equals to 7. So px equals to 6 plus px equals to 7. The probability when x equals to 6 is 0.2. When x equals to 7 is 0.1. So the answer is 0.3. Okay, number 5. Find the probability when x less and equals to 3. So from the table, we can see that when x less and equals to 3 means we can take the value of 1, 2, and 3. So we start from 1 plus px equals to 2 and px equals to 3. The probability when x equals to 1 is 0.1. X equals to 2, the probability is 0.2. When x equals to 3, the probability is 0.1. So we add up all the probabilities and the answer is 0.4.